Okay, we'll continue with two word problems from Chapter 4, Section 2 in this video, and we'll go on from there. So, modeling with mathematics. You pay a processing fee and a daily fee to rent a beach house. The table shows the total cost of renting the beach house for different numbers of days. So, notice what's happening here. We have for 2 days, 246, for 4 days, 450, 6 days, etc. So we can see that the number of days is going up by 2, and when that happens, in order for this to be able to be modeled by a linear function or linear equation, since the x change is the same, the y change will have to be the same as well. And so we check 450 minus 246. That comes out to be $204 difference. And from 654 minus 450, we're going to get, again, $204, a consistent change in y for the same consistent change in x. Next, 858 minus 654, and that is also 204. So to find the slope, we have the change in y. Make sure you put the change in y on top over the change in x, and that gives us a slope of 102. So can it be modeled? Yes. The slopes between all pairs of points are the same, or is equal. All right, so then we're going to take our equation and we're going to, or take our slope and one of our points. We only need one. We'll call that x1 and y1. And we'll plug it in. Y minus y1 is 246 is equal to m, which is 102 times x minus 2. Multiplying out, y minus 246 is 102x minus 204. Adding 246, adding 246, we end up with y is equal to 102x plus 42. All right, what is the processing fee? Well, the processing fee is the $42. Processing fee, how do we know? That's a one-time charge. Doesn't get charged every day. But what is the daily fee? It is $102. All right. Now you can spend no more than $1,200 on the beach house rental. What is the maximum number of days you can rent the beach house? Well, one way we can do this, and there are a number of ways. One way we can just continue to move outward to add on 2 more days. We'll have 10 days then. Add 204 again onto that, and we will get $1,062. By adding another 204, we're going to exceed $1,200, so we can only add 1 on in that case. That'll bring us up to 11. We don't add 204 this time, we add 102, and that will bring us to $1,164. All right, another way that we could do this is take our equation and set it equal to 1,200. So 1,200 is equal to 102x plus 42. Subtract 42, subtract 42, and we're going to get 1,158 is equal to 102x. But when we divide 1,158 by 102, we end up with x is equal to 11.2. 3, 5, which means we could stay 11 days and a third of another day, but the hotel's not going to, or the beach house is not going to let you rent a third of a day, so we can only stay 11 days. All right, and so we showed two different ways of finding that. We'll go on to the next problem. All right, in the next problem, we have three siblings each receive money for a holiday and then spend it at a constant weekly rate. The graph describes siblings A spending. That's graph, so we'll label that sibling A. The table describes sibling B's spending, and the equation here describes sibling C's spending. So, which sibling received the most money? Well, again, if you look at the equation or the graph or the table, the money that is received is the starting amount. So let's make a quick table here. All right, so how do we know how much money person A or sibling A started with? Well, it's going to be the y-intercept on the graph. And so sibling A started with $80. Now, sibling B, we don't have the amount for week 0, which is what we really need. So we're going to have to go backwards. We're going to have to first find out how much they're spending each week, and hopefully it's a consistent amount. So we can see that their money is going down by $25 a week, which means that their starting point at week 0 minus $25 from week 1 would be $75. And so tracing backwards from 100, if they're spending 25 a week, they would have started with $75. So it's very important. We're looking at graphs, we're looking at tables, and now we're going to look at an equation. The starting amount would be the y-intercept, which is the $90 amount. So that's a sibling that started with the most money. So we'll call this most, and we'll call this least. All right. Now, which sibling spends money at the fastest rate? Spending. Dollars per week. All right. How do we see how much they're spending? We see how much they're spending by how much the money is going down each week. Well, for sibling B, it looks easiest to tell. They are spending $25 per week. Now, what is that? That's the slope of the line. For sibling C, they are spending $22.50 per week. And for sibling A, we're going to actually have to calculate that, and that would be y2, which is 20, minus y1, which is 50, over 4 minus 2, and we're going to get negative 30 over 2, or negative 15, which means their money is going down by $15 a week, or they are spending $15 a week. Who spends money the fastest? Fastest would be sibling B. Who spends money the slowest? That would be sibling A. Now, which sibling is going to run out of money first? Well, that's asking the question, how long is their money going to last? On the graph, we can see that the money will last until it becomes 0, right? So, again, for sibling B, this might be easiest to calculate because by week 5, we subtract another $25, and sibling B is out of money at 5 weeks. All right, now the other two, a little more complicated. We can't tell for sibling A just by looking at the graph, but we know it's more than 5 weeks. What we could do, we have a slope, we have a point, so we're going to create an equation. y minus y minus y1, we'll pick the point 50, equals negative 15 x minus 2. Now, if we wanted to, we could just set the y equal to 0 there. That would be the easiest way for us to find this out. Y is equal to 0. Or we could find an equation and then set y equal to 0, but this is just as good. We want to find out when does the money run out. We distribute, we get negative 15x plus 30. We add 50 on both sides, and we end up with 0 is negative 15x plus 80, adding 15x to both sides. Again, there are more than one ways that we could have carried this out, is equal to 80, and then we'll divide both sides by 15, and we end up with x is equal to 5.3, repeating. So that's about 5 1/3 weeks. So this would be, again, for person A, sibling A, 5.3 weeks. Now, the only thing we don't know is sibling B. And so sibling B, we're going to do a similar type of a thing, or rather sibling C, I'm sorry. I'm going to scroll down just a little bit, give us a little room to work with here. For sibling B, we have the equation. Go back up. I'm sorry. Sibling C, the equation was negative 22.5x plus 90. So y is equal to negative 22.5x plus 90. And again, all we need to do is set y equal to 0 to find out when the money runs out. This time, I'll simply add 22.5x to both sides. When I do, I get 22.5x is equal to 90. Dividing both sides by 22.5, not x, but just 22.5, gives me x is equal to 4. So, who runs out of money first? So that would be first, would be sibling C. Whose money runs out last would be sibling A. And so we have to know how to work with linear equations in equation form, graph form, table form. When we don't know the intercepts, we can find slopes, we can find y-intercepts. We know how to interpret the y-intercept. That's the starting amount. We know how to interpret the slope. That's the rate at which they're spending. We know how to interpret the x-intercept. That's when they run out of money. All of those things in these equations are very important, and on these graphs and in these tables. They all have an interpretation in the context of the problem. So that'll do it for this video and for chapter 4, section 2.